In the agentic world, that makes a lot of people really uncomfortable because what ends up happening is the agent has its own ID and then interacts with your database.
Hey everyone, and welcome back to the Modern.NET Show, the premier .NET podcast focusing entirely on the knowledge, tools, and frameworks that all .NET developers should have in their toolbox. I'm your host, Jamie Taylor, bringing you conversations with the brightest minds in the .NET ecosystem. Today, Jerry Nixon returned to the show to talk about SQL MCP Server, something of a new product, and the evolution of Data API Builder, which we talked about with Jerry back in episode 3 of this season. There will be a link in the show notes. Jerry does a much better job of introducing it than I can, but suffice it to say, SQL MCP Server is an MCP server which abstracts away interacting with a SQL database of almost any flavor. SQL Server, Cosmos DB, Postgres, you name it.
I mean, there is nothing better for any agent than saying new session. Like, that is how you create better answers all the time. You might feel like you have this session, you've been training it so long and you've told it so much, it has so much context that now when you ask it, it'll finally have the answer that you're looking for.
Along the way, Jerry shared a lot of solid gold nuggets of advice about MCP servers, best practices for interacting with agents and models, and even context management. And of course, we talk about how simple is almost always the best solution, and how SQL MCP Server might be one of the ways for you to achieve that. Before we jump in, a quick reminder. If the Modern.NET Show has become part of your learning journey, then please consider supporting us through Patreon or Buy Me a Coffee. Every contribution helps us to continue bringing you these in-depth conversations with industry experts. You'll find all the links in the show notes. So let's sit back, open up a terminal, type in .NET New Podcast, and we'll dive into the core of modern.NET. So Jerry, welcome back to the show. Wow, you were on the show right at the beginning of Season 8, and you will also be the final episode of Season 8. So you've bookended the season. This is awesome.
I am the alpha and the omega, Jamie. This is absolutely incredible. Well, don't let the lightning strike me. I just think at the beginning and the end.
Awesome. So we're going to be talking about some stuff in the episode relating to SQL and relating to MCP and presumably to agentic stuff. But I figured in case folks didn't catch the first episode, and you should totally go back and listen to that episode, folks, because we talked about the amazing Data API Builder. I wonder, could you give folks like a really quick, we're in an elevator, you're going to introduce yourself to somebody. How do you do that? Like, what's the kind of stuff that you do over at Microsoft?
Yeah, programmatically, you want to interact with production data. You either have a REST API or a GraphQL, a kind of API against it. You write a custom one, or you use an engine like Data API Builder that does it for you in a nice, secure, feature-rich way. That's where Data API Builder really kind of sings, because it allows you to delete a considerable portion of your code base that's just repetitive code that you don't really need. And it gives you this really robust and secure API that you can use across all of your databases and all of your applications. And it's deployed as a container or not, just depending on how you want it. That's Data API Builder. And probably the most important thing to say is it's an open source free project from Microsoft. So you can use it on-prem or in another cloud if you want to, and pointing against any of the Microsoft SQL databases or Postgres or Cosmos DB.
I really like that. We talked about it a lot in the previous episode. So folks, if you're interested, give that a listen. But yeah, I love that it's open source. I love that it works on all the SQLs, or at least the ones you mentioned.
That's right.
And, deleting code is that's the best way to add new features. It's just to remove code. Like, removal of code means that you have fewer places for bugs to appear, right?
That's exactly right. There's so much opportunity for error, and less really is more. And if I were to say one other thing about Data API Builder is that when you and I spoke about it, not really that long ago, we hadn't gotten to version 2.0. And so since I've spoken to you, 2.0 was released as public preview, and we released general availability just yesterday on the 22nd. And so not yesterday, I guess it was last week. But nonetheless, 2.0 is now out, and it's all the features that we wish we had had before. And so the previous iterations of DAB were really amazing. These new iterations, or I'll say these new releases that we have today, They are just everything. It is such a compelling story. And so when we talk about SQL MCP Server today together, we're going to be talking about Data API Builder too, because they are part and parcel.
Nice. I love that. When a plan comes together, we've serendipitied our way into V2 of Data API Builder at the same time as SQL MCP Server. I love it.
Yeah, well done. Yeah, it's serendipity. I've never heard of the verb version of that. Excellent use.
I think we just made it into a verb. That's what we just did.
The evolution of the language right here.
Absolutely.
So let's dive into it, because this is a deep subject. It really is.
Yeah. So I know through my own experimentation, my own learning through the show and all sorts of things, that MCP stands in this context stands for Model Context Protocol, right? So I can do something with my agent. Maybe it's Copilot, maybe it's Claude, maybe it's whatever, right? There's a whole bunch of them. I might be using one on the cloud, might be using one on-prem, whatever I'm using. I can say to an LLM, and this is my understanding of it, so please correct me if I'm wrong. I can say to an LLM, hey, there's this MCP which exposes some tools that if I ask you questions related to or give you tasks related to what the tool does, go use the tool instead of grepping and sending HTTP requests and trying to connect to the database yourself or anything like that. Use this tool. The tool knows how to do it. It will help you to achieve that solution. Just to sort of level set, is that kind of, am I on the right tracks as to what an MCP is?
Yeah, you are totally on the right track. Let me give you an example of maybe we could kind of think of it as an onion. It's really, there's so many analogies here, but if we start with an onion, at the heart of everything is an LLM. So you have this model that's able to do this prediction analysis. And on top of that, to make it run, you would have an agent. And the agent would be the invocation piece that makes the LLM work. Well, that agent doesn't really do anything, right? It's just a program running in memory. But that agent needs to now talk to a database. Well, an agent doesn't know how to talk to a database, nor does it have a database driver installed in it or anything along those lines at all. If you do want it to fetch data or update data or do anything with any system, not just a database, you have to have some sort of intermediary, and that's really the MCP. So MCP is the one thing that all modern models do understand. They understand that signature protocol to be able to talk to it. And just to demystify it a little here, it's just an HTTP endpoint. It looks and acts exactly like REST. It just happens to have a response structure that is very standard, and it accepts in a request structure that's very standard. That's the MCP protocol. It's not a new type of protocol. It's not a new way of communicating. It's still HTTP, and it's still JSON, and it's still very simplistic. It just happens to be the consensus now across all of the models so that they understand how to do it. And so if you have an agentic solution, then you want your agent to do something. If it's going to do something, you want it to use an MCP. And an MCP is very thin. It doesn't have to be some gigantic whatever. It's just the gateway that allows it to do whatever is on the other side. So if you wanted your agent, for example, to turn on, the light on your porch, you would write an MCP server that has the same signatures and same structure the MCP standard requires or prescribes. And then on the other side, you would just have the simple logic of turning the light on and off on your porch. That's an MCP server. It's definitely not, splitting the atom. And what we're talking about today is the SQL MCP server. So an MCP server specifically designed to interact with a database on the data plane. And the reason I make that distinction of the data plane is because a database has several planes. The first plane that we all experience is the control plane. So that's where I would create the database, provision perhaps security on that database, figure out which files it might live in if it's not on the cloud, or which cloud it lives in if it is. That's the control plane. And this is not what we're talking about. There's another MCP you would use just for that, dedicated for a specific family of purposes that would be targeted to an agent that is used by some sort of administrator. That's very reasonable. Then the next plane after control then is the schema plane. That is where you would be creating brand new tables. You would be dropping columns, creating columns, altering data types, creating relationships between them, and on and on. Everything that we would call in the SQL world DDL, right? That's the description language, the data description language. It's where you create the actual objects, not the data, just the objects that are intended to hold and manipulate them. And so that plane, yet another plane that we're not dealing with right here, you would create your own MCP, or you would reuse one like the MS SQL extension in VS Code that is intended for the developer loop, where I'm trying to brainstorm through what would be the right way to store this data. How could I have a table like that? And maybe you're using an agent like Copilot built into VS Code, or you're using Claude or Codex. It doesn't really matter. All of those then can interact with that type of schema layer, constantly iterating on the structure of your database until you're satisfied, or perhaps even making changes later as you start to evolve. But then this third layer is the data plane. This is perhaps the most important if you really think about it, because though everything is important, this is the one that gets used and just beat up forever. This is the one where all your users are interacting with your data. And in the SQL world, we would categorize this as DML, the data manipulation language. And so this is the SQL that I would write, not to drop an object or create an object, but this is the SQL I would write specifically just to manipulate the data. That includes reading the data as well. And one extra piece is perhaps executing a stored procedure. So as your users start to engage your agentic solution against an agent, and that agent needs to now talk to your database, that's where we go with SQL MCP server, exposing the data plane through the MCP's protocol and specification to make sure that it's compatible with your agent. And that's where the power begins. And SQL MCP server is unique. And I would say unique with a capital U, because we as developers, we naturally are drawn towards simple. And there are things to remember as you're drawn towards simple to make sure that security isn't the compromise, and to make sure, long-term maintainability isn't compromised. And there are many things around that push against simplicity. The simple thing in an MCP server that we are drawn towards is this idea of NL to SQL, or natural language to SQL. This is where I would type in my prompt, whatever it is, that's the natural language. And then the query that's being written, not executed, but written, is written by the model. It writes the, select this from table, and here's my where predicate. That gets passed to an MCP server, executed against the database, and the data is returned. That's very appealing because of its simplicity. It's easy to explain, it's easy to understand, you can visualize it, but it is replete with problems. And the number one problem is these models that we interact with are incredibly powerful, but the one thing they aren't is deterministic. That means I could ask the same model, the same prompt, and it would provide potentially a different query, a different query every time. And even if those differences were subtle, the impact could actually be quite significant. So on the one hand, you value the autonomy of an agent to be able to accomplish tasks on behalf of the user without their involvement. But if it's a indeterminate query every time, that lack of determinism means you now have to review the query. And if you don't review the query, then you're really just closing your eyes and praying that the query is going to be fine. Because even though you may have unit tested the production of this query against the model 100 times, there still is no guarantee the 101st time is going to be the same. But this now takes away the entire benefit of agentic solutions, making it so that instead of being able to enjoy the autonomy of the agent accomplishing a task for you, you now have this additional double burden of, one, understanding the underlying data schema sufficiently so that you can recognize whether or not the query is correct, and two, knowing the query language sufficiently so that you can see the subtleties of it if there happens to be a mistake. And we're not really talking about the problem of, the agent dropped my database. Oh, the agent dropped my table. That's a concern, but something we can resolve really with security. What we're really talking about is a query that gets executed against my data, returned back as a response that looks correct and is presented to me by a model that is disproportionately confident in that data when it's wrong. And now I look at that data and I make decisions in my business thinking that this data that I am using is revealing information inside of my data set when actually it is misleading me. It's not really a question or a category of maliciousness. It's not like the model's trying to ruin your business. The model just got it wrong. And now it is ruining your business.
Right. If I can just pause there then and talk about what I'm hearing then. So the SQL MCP server allows me to have my agent via the LLM, interact with the data plane of my data and say, for instance, if I have an internal tool that I release out to the data people, or maybe the people in my business who are very interested in gathering data and massaging it, putting it into some kind of report, I can say, hey, you can use this MCP server, or you can use my app. You don't need to know it's an MCP server. You can use my app that I've built internally.
That's right.
That can talk to the database, and I can say in natural language, get me, for instance, the sales by category for the last quarter, and just get me those, right? Put it into a JSON table so I can display it on screen. So then maybe I can export that to say Excel or something like that, and create a report based on what we sold in the last quarter. Is that kind of? But then it will then go to the database. It will do whatever. I don't need to know what it needs to do. My end user doesn't need to know which queries it's running. It's just going to go, select star from wherever, with this where clause, ordering by this, grouping by this, shaping that data, returning it to the user. And then the LLM can then go, cool, I've got all this data in whatever format. Maybe it's a table, maybe it's a JSON blob. And I can then massage that data, not in the way of changing the numbers, but changing the presentation of it for the user in front of me. Am I in the right ballpark?
Yeah, you really are. And so remember, though, this isn't really an API. So you wouldn't use an MCP server with the intent of getting back the data so you can present it in a table. Instead, you're really letting an MCP server be the access point for the agent. And the agent is just simply trying to answer a question. So let me give you an example, Jamie. You might ask and say, last quarter, which of my products sold the best? Right? That's not really a table that's coming back, if you see what I mean. You just want the answer, and or which one did the worst. More importantly, you would try and come up with a question that is a little more exotic, right? Like, who is my most valuable customer? Right? That's pretty exciting because now you're saying, all right, agent, you have access to all these tables. What if you could just do whatever you wanted until you could answer this one question, and it will iterate internally and attempt to answer this question for you? That's the value of having an LLM. Right? We're not building screens in line of business applications anymore. We're just presenting this problem to the LLM or through an agent, and then it is processing and iterating, trying to find the answer. That's where probably the biggest risk comes, is if it is producing queries that are slightly inaccurate, the final answer is dramatically inaccurate. And it's difficult for us to have that sort of answerability. Like how can we go in and figure out how they figured it out? And so not having your agent, not having your model write SQL is an important first step. And there will be stages where that may be valuable, but generally speaking on the data plane, it's nicer not to do that because you want to be as deterministic as possible. So your model knows it wants to find your products that are all sold on the East Coast that are under $20, let's just say. Well, that's actually a very nice recipe that can be constrained down to guardrails inside of your MCP API. And then the way SQL MCP works is once it provides the request, the query builder inside of SQL MCP server writes the T-SQL. So that means the thinking is still going on in the LLM, but then it presents it as I want this value, I want this predicate, I want these things. And then SQL MCP server says, all right, I understand what you're asking for because I've given you these guardrails across the entire schema or limited schema, depending. And now I will take it and construct the SQL for you. Our construction of SQL is deterministic every time. And we're very good. I mean, we're the SQL team. We're very good at writing SQL. And so the resulting SQL is not just reliable from it's always the same point of view, but also reliable from it's a good job. And we still give back the answer to the LLM. It just, we don't add the additional burden of the LLM to create the valid SQL.
Right. Okay. To make sure that I correct my understanding, then previously I had said, hey, agent, go use the MCP server. Something, I think I'd referred to maybe the agent would say select star from, but actually the agent is talking to the MCP server and saying, I want this information. I don't know how to get it. You need to get it for me. I know that my user wants me to get, like you said, maybe products that are sold in this area that have a value of less than $20. I don't know what the data plane is. I don't know what data store it is. Hey, MCP server, you go figure it out. Go do the thing, right?
Now you got it.
And then maybe the MCP server runs a whole bunch of different SQL that I can't see, that the agent can't see, that the MCP server isn't exposing. It does some stuff, returns with that data and goes, here you go, LLM. This is the answer to the question that you asked me. Am I getting it now?
That's right. And that surface layer is not just a guardrail, but it's also an abstraction layer that makes it possible for the backend data source to be a Cosmos DB or a Postgres database. And you don't have to worry about changing your SQL or whatever. And then now the LLM needs to know the backend data source and which version it is, so it's all correct. We do that work. It just is identifying each of its components. Like, I need to know the warehousing information, I need to know all of the inventory information, and I need to know the product details. Then we construct the various queries behind the scenes, bring those back as a unified payload.
Right. Okay, so there's some opaque box there that Yoel and the SQL team are creating for me. I guess a little bit similar. I don't think it's exactly the same. I don't think it maps one-to-one, but like for the folks who maybe haven't used DAB, definitely haven't used the SQL MCP server, but maybe, a lot of us have got experience with maybe using Entity Framework, and we can say to our in-memory DB sets, hey, products dot, and then I can use link to, I can either use link to see, is it link to SQL? There's two different types of link, right? There's the dot annotated link, and there's the from collection where, right? And I can use that.
Yeah, link and lambda, or the methods.
That's it. Yeah, thank you. Yeah. And when I do that, somewhere behind the scenes, Entity Framework talks to a specific driver for the database that I've told it about and generates the SQL. But I think the difference, please correct me if I'm wrong, but the difference here is I don't need to tell the MCP server which driver to use. I maybe have to point it at the database and it figures it out. But like from a agent talking to the API, I guess, of the MCP server, I don't need to go into this table, go into this collection, use this driver to generate the SQL. I as the API, as the agent, could just say to the MCP server, I want data, right? I want this data in this shape, in this, about this thing. And then the MCP server, the SQL MCP server does whatever magic it needs to, generate whatever SQL and point it at, and it will then go to whichever database I need. I don't need to, like you said, it's an abstraction, right? The database is now an abstraction. It's like I push on the gas pedal and my car goes forward. I don't need to think about, I push on the gas pedal and, gas is injected into the engine and a spark fires and it explodes, which drives the piston, which then converts into rotary motion, which then turns the wheel, which itself is all an abstraction, but I don't need to think that level, right?
That's an excellent explanation of it, actually, because that is the intent, is to make it so that we don't dilute the context of the model with extra information that really it shouldn't have anyway. And so it's not even, it is an incredible benefit from a security point of view, but that's not really the driver. The driver is, how can we make these models more successful in interacting with the data while ensuring that we protect the data? So remember, I could write an MCP server at any time that allows the model to write the query and just pass through and execute it in SQL. The problem is the database itself is, well, we just need to think about a production database as the most valuable asset of any company.
Mm-hmm.
And so we want to reduce the surface area and the risk against that, making it so that all of the things that can happen inside that database are going to be limited to or constrained down to a simple set of operations. And one of the ways that we can limit it is through security. And so in a typical line of business application, the security model might be like this. I log into my application using, let's just go with an intra ID. That then has my token, but it has its own application ID inside my tenant, and it logs into the API, which has its own tenant registry, which logs into my database, which also has a tenant registry. Each one kind of along the way validating the caller before it goes through the chain. That's just the table stakes bread and butter for everybody who's building an application today. That's the way APIs are written, and that's the way security is 90% of the time, if not more. In the agentic world, that makes a lot of people really uncomfortable because what ends up happening is the agent has its own ID and then interacts with your database. Well, even though that technically does work and is fully functional, it is a little awkward because when you're looking at the audit trail of who did what, you now are at the point where it's almost like digging a hole and the shovel has its own identity. Well, I'd rather know that, the worker who has the shovel, that's the person who cut the line. That's the person who dug too deep. That's the person who did whatever. And so on behalf of authentication, which is very rare to implement in an API scenario, is what we really are striving towards in an MCP scenario. That's because now the one that is operating against the database is the one who invoked the model in the first place. So if it's me talking to an agent talks to an MCP, the MCP talks to the database, it is still me and my token that is in the audit logs of the database. That's particularly appealing when you think about it from a security point of view. And it's one of those things that you're like, well, how are you going to build your MCP? Okay. Well, how are you going to abstract all the data? Okay. Now, how are you going to do data or authentication? And then how are you going to do authorization behind the scenes? Are you going to have RBAC at the API level? Or are you going to have RBAC at the database only? Is it going to be all through the solution? It's fascinating, really, how many questions there are to answer. And it's, again, one of the primary reasons we built SQL MCP server, because it deals with all of these things for you. You just configure that JSON file and we do it from there. And you had pointed out how similar this is to Data API Builder, because this is Data API Builder behind the scenes. And so Data API Builder has a REST endpoint, a GraphQL endpoint, and an MCP endpoint, which means one JSON configuration file against your database can provide all three solutions or individually, however you want to set up your topology.
Wow, that's really cool. Yeah, especially for folks who haven't used Data API Builder at the moment. One of the things that I'm talking about a lot on the show this year, Jerry, is I'm realizing that I, as someone who speaks to folks like you, kind of am at the forefront, whereas perhaps most of the day-to-day, especially enterprise-level .NET devs, don't get much of a chance to try out new things because they hear about something on a show like this, or they go to a conference and they go, my goodness, that would be awesome. And then they go back to work and they're like, right, okay, so I'm building my forms over data app and I'm using Entity Framework, whichever version is, whichever version fits, whichever version works with the version of the SDK that I'm constrained to because I may not have the time to upgrade. For those folks who haven't used Data API Builder, it is literally that. Jerry and I spoke about it on the previous episode, but it is a case of you create a JSON file which represents all of the things to do with connecting to your database, and then Data API Builder just figures out an API for you. It is fantastic.
Yeah, even if, I love Entity Framework, and I totally understand why it's so appealing to developers as well, because it eliminates it eliminates the need to know T-SQL, the need to really understand, how to build structures inside of SQL. It does it for you with migrations. And so I totally get that. However, there's going to be this crossroads, we'll say, where the size of your database is so significant, where the scale of data is so significant, where the complexity of your objects is so significant, or frankly, the maintainability of your application is so significant, where you're like, I kind of feel a little discomfort in my Entity Framework solution. And that's because it's kind of pushing up against the boundary that it has. Can it be done? It can always be done. We are engineers. With enough time and money, we can get it done. We can make it work. Is it the right solution? And so you're absolutely right. Data API Builder sort of steps in the gap and says, 9 out of 10 times, all you really are doing are CRUD operations against your database. Let us do that for you. But we also recognize that, 1 out of 10 time, you have to do something special, whatever that might be. And maybe Entity Framework comes back into the picture. That's totally fine. A mixed solution like that isn't wrong because you've still isolated so much of your code, especially the CRUD code, away to this dynamic engine in Data API Builder. And then once you have Data API Builder in your solution, then your boss comes to you and says, this needs to be agentic. AI is, everybody's talking about AI and our investors just asked about it and we need a story. Well, it turns out all you have to say is MCP enabled equals true in Data API Builder, and it transforms into SQL MCP server. So Data API Builder really does have two names, right? There's Data API Builder and there's SQL MCP server. Two names for the exact same engine. There's no difference. If you disable MCP and SQL MCP server, I suppose that's the difference. But in all reality, nobody was Googling Data API Builder with MCP capabilities. Everybody was Googling SQL MCP server. So we, take this moniker of SQL MCP server and drop it on Data API Builder, but it really is the same thing. just depending on how you approach it. And the nice thing is, I was describing how you could have a REST API against your database that's nice and robust, and you just enable MCP. Now you can have both. But you could go the other way as well. You could start from an agentic side, and you're doing everything with SQL MCP server. And then you're like, I would like to have this tiny little admin app that did this thing and this thing. Well, now I can enable REST or GraphQL as well with that same endpoint. And I don't have to introduce a new piece of architecture. I don't have to, spin up another anything. Everything is right there. And because it's open source and free, and there's no license. So, MIT license, but there's no significant license to consider. I can move this on-prem if I need to. I can have it in AWS if I need to as well. And so it's just nice, right? Because it's like, oh, now we have an MCP server. Where do I install that? And like, surprise, you've already got it installed. So it's very appealing to have so many solutions in a single engine that was already pretty nice to use. And for your listeners who maybe didn't hear that first episode, just as a reminder, this is the engine inside of Microsoft Fabric that exposes the GraphQL API endpoint there. So just from a perspective of secure and robust and scalable, that's sort of proven just because of that. And so we're glad to give it away because it reduces the friction of any developer trying to interact with the database. So if you're drawn towards Entity Framework because it removes the intensity of writing all of these queries, that's the value of SQL MCP Server or Data API Builder, because it also does the same thing, making it so your engineers or your application interacts with the database just over HTTP and JSON. And so it's nice to have the same story that we have for APIs and line of business apps is the same exact story we have now for agentic applications as well. So we get to reuse that robust query engine that we have inside of Data API Builder. When we say things like pass-through authentication or on behalf of authentication is really important for agents, well, as soon as we enable it for agents, you also get it on the API side as well for REST or GraphQL. So it's really cool to be able to build into this. And every time we add a feature, it's across all of the use cases.
Do you see that? Oh, I love that because it's something that you've sort of hinted at earlier on when you said, as developers, we love the idea of a simple solution, right? We're drawn to simplicity. And there was something you said last time you were on the show, all those months ago, about simple is always the best solution, right? A simple design is always the best solution because it's easier to think about, it's easier to reason about, it's easier to secure. And especially to your point there that you made earlier on about if I am using an agent with an on behalf of token or some kind of on behalf of identification, authentication, authorization, then like you said, it can be traced back to me. So if you do end up with a malicious user or someone doing something a bit silly, you can figure out who it was that did it. But if you have just an agent working directly against the database, maybe writing its own SQL.
It's a mystery.
Yeah, right. It maybe then needs to create a little Python app to talk to the database on your behalf. You don't know who gave the LLM that instruction or rather, you don't know who caused that SQL to run because there is no connection there. So yeah, I love that idea of being able to not necessarily trace things back for a malicious reason of like, hey, you're using a billion tokens and you're causing bottlenecks in the database, but more a case of somebody dropped the production server and we need to know who did it.
Right. Yeah, that's exactly right. From authentication, it's so important. And what's nice is when you when you choose a robust engine like this, you don't have to think about authentication until it's time. And then when you're there, you don't have to back out of all these compromises. You just enable it. So that part is nice as well. It should help you sleep at night knowing that you're going to use an engine that when we get around to figuring out how complex the authentication needs to be, it probably already supports it, right? And so I think that's an important kind of place to be. By the way, so last week, I was in an architectural session with a bank customer of Microsoft, a really large bank that would be easy to know by name. And when they get to the point where they're like, all right, who do we give authorization to inside of the database? And option number one, you authorize the agent to do something. And that was the showstopper. They're like, we're never authorizing an agent because that's like giving authority to the hammer, giving authority to the shovel. And we're going to give authority to the people, and then they can go through it. And so it's really nice because when you start talking to people, their entire job is to safeguard the integrity of the data of your business. they suddenly start caring about things and they're like, we're not really interested in whether or not it's easier or not to engineer this. We're talking about the security solution and it's going to go this way. And it's interesting to me how it can really be the trump card that's played. And it's like, oh, okay, well, we thought we were going to use Entity Framework and we were going to do it the easy way. And they're like, great, rewrite everything. And so it's just nice to be at a place where it's like changing the channel on a TV. Well, which authentication model should we use? And you just switch to the one that eventually you get to a point where whoever the guardian of your production data is, they'll have these requirements. I was on another architectural call with a State Department in Scandinavia, and they were approaching it from a different point of view. They had data that was available, and it was publicly facing data, but the only way they could expose it to anybody on the outside was to give database logins to the users and then show them how to kind of have touch points into that. Basically launching SSMS from a customer's perspective and then connecting into SQL Server. But they would have security, but it was a terrible thing to manage. You could just see how clunky and terrible that is. And what an awful experience it would be for the customer. And so they see it another way. They see it like, let's take our data and let's translate it into being a clearinghouse. So they, instead of building an application that has an API endpoint, they built an API endpoint without an application. And it dramatically improved the scenarios for all of their customers who have no problem talking to an API surface. They weren't looking forward to using SSMS or anything like it anyway. And so then they're like, oh yeah, now there's a new initiative inside of the entire government to have these agentic protocols. And it turns out you can say MCP enabled equals true. And the same thing that you just built 6 months ago is now an AI solution as well, without having to introduce all of the caveats that usually come along with it, with raw access and weird security and all of these things. So it's really cool. I mean, I've had a tremendous opportunity to talk to different customers and the way that they're using it. And I would say that the most practical sense is I want to build fewer screens inside of my application. I want to instead ask my agent to do things for me. As it does things for me, it just needs the CRUD operations against the database. That's the nice, step number one. Step number two, though, would be information discovery. And information discovery is amazing. It is perhaps the pinnacle of the way we'll use agents in the future. And it's basically where we say to the agent, we don't know really what we have here, but I think you could find our next big opportunity. And just go to town. And this is a long-running request, that you would prompt an agent to do. And it would just, it would, not to say beat up your database, but it would just run many queries, trying to find patterns and trends that you didn't anticipate. And so this idea of information discovery is really beautiful because it can come back then with an answer to a question you didn't really even know you were asking. And that you want to be able to provide access to also. You don't want to just say, here's the very simple, nickel and dime ABC CRUD operations. You also want to have this broad reaching, expansive sort of access to the database where on the back end, you've probably created a read-only replica and you've made sure you're not going to impact, production activities. But you also want to have an agent now just go and research. And so both of those are scenarios that we intentionally built for with SQL MCP Server. And so we have a handful of tools. A normal context window of an LLM is limited to a certain number of tokens. Well, that token window is actually much smaller than people realize. Even though you might see a window of 1 million tokens, there is no LLM that has 1 million token window because the input and output by themselves kind of share that limit. And so now you have this input limit of a certain number of tokens. If you provide too little, it's naive and can't really do operations. If you provide too many, then it's overwhelmed and probably diluted, so it's not able to make good decisions either. So you want to stay sort of in this middle ground. Well, one of the most important ways to stay in this middle ground is to make sure that the tools that you provide to it don't overwhelm it with too much information. And what I mean by that is I could provide an MCP server of any kind with 100 tools. And by the time I got to 100 tools, because every tool will have semantic descriptions, every tool's parameters will have semantic descriptions, and every tool's result types will also have semantic descriptions. That's really important to make sure that the model understands what it's about to do and how to use the data that's going in and coming out. I have 10 tools, let's say. That's a lot of information. I have 100 tools. Now that's really serious. So create, read, update, delete is 4. Operations against the table. I have 10 tables. That's potentially 40 tools. I have 100 tables. That's 400 tools. It's a guarantee that I'm about to overwhelm the context of these models, and their ability to process like reasonable answers to our prompts dramatically falls off the cliff. So the way SQL MCP server does it is we provide built-in tools, and we provide seven built-in tools that make it so that we can have all of this robust interaction without constantly growing. And what's nice about that is it says if you have a database with 10 tables, you have 7 tools that you'll provide to a model, very manageable. If you have a database with 1,000 tables, you have an MCP server with 7 tools that you provide to a model, still very manageable. So we have this sort of scalability answer as well to make sure that if you have an incredibly robust database that has all kinds of objects in it, you still have the opportunity to provide that back to these models without blowing their context out of the water. So just so many little things to think about that we've had to like incorporate into SQL MCP server to ensure that it's the right answer for small student developers who are just trying to get started, startups who maybe have a small, modest database, or these enormous customers that are just enterprises that you can't believe that are customers of Microsoft. So SQL MCP server is quite the answer across the entire spectrum of customers.
Today's episode of the Modern.net Show is brought to you by RJJ Software, strategic technology consulting for ambitious SMEs. You know me as the host of this podcast, but here's what you might not know. I'm also a Microsoft MVP who's helped businesses from Formula One teams to funded startups to transform technology from a cost center to a competitive advantage. At RJJ Software, we specialize in 3 things that matter to growing businesses. AI that actually delivers return on investment, not hype, just practical implementations that pay for themselves. Developer experience optimization. We've helped teams to achieve 99% faster deployments and 3x productivity gains. And strategic technology decisions, from architecture reviews to fractional CTO services. The difference? We don't just advise. We ensure successful implementation through knowledge transfer to your team. If you're an SME leader wondering why your technology investments aren't delivering, or if you're facing critical decisions about AI, modernization, or team productivity, let's talk. Visit rjj-software.co.uk/podcast to book a strategic consultation. Now let's get back to today's episode. I really appreciate you saying about the context window there and not overwhelming the underlying model. I'm currently reading through a book called Agentic Design Patterns. It's from earlier in this year, so it does talk about prompt engineering, but it talks about this idea of you don't want to give a model too big of a set of things to do all at once. So you might, instead of saying like as one prompt saying look through the data and build me a report about the thing, you might say go get some data and summarize that. Cool, I've done that. Here's the summary. Great. Now that you still have that sort of data around, look for trends about X, Y, and Z. Okay, it goes and does that. Cool. Okay, now build me a report and maybe be sending those, forwarding those prompts to and the data to slightly different models. One that's maybe better at writing prose, or one that's maybe better at visualizing data, right? Splitting those into smaller steps. And if you've only got 7 tools to do it in, then that's only 7 tools that but that's probably the wrong way for me to put it. Let me take that again. And we'll leave it in, but let me just make my point again. If you are able to expose all of the things required to interact with the database at an abstracted level, regardless of the number of tables, through only 7 tools, then there is absolutely no way from the tool count point of view that you can overload and I'm worried about saying confuse an LLM, but, cause hallucinations and cause it to lose track of where it is and things like that, because there are only 7 tools, right? If I sit you down and give you a toolbox with a hammer and a wrench and a saw and maybe a plane or whatever you call it for shaving off bits of wood, right? And I say to you, build me a handle, right? You're only going to use those 4 tools. But if I give you a toolbox with 1,000 tools in it of all sorts of different kinds, maybe a different kind of file, a different kind of 4 different hammers and 12 different saws, you're going to have trouble figuring out which tool to use to create the handle for the hammer that I've just told you to do. So absolutely, I fundamentally 1000% agree on the reduction of tools exposed by an MCP, because I've worked with teams previously in the not too distant past where someone will get, I'm fearful of the phrase, but like MCP joy. Oh, there's an MCP for this. I'll install that. Oh, there's an MCP for this. I'll install that. I'm never going to use them, but I'll install them anyway. And then they'll fire up a new instance of their model, their agent, whatever, start a new session, and they realize they've overloaded the system context immediately. And I'll say, well, and they're complaining, why? What's going on? And I'm like, well, how many of these MCP servers that you're not using have you got installed? And they haven't understood that when you have them installed, it has to tell the model, hey, I have these tools and these are my descriptions for these tools, and here's how you can call these tools, regardless of whether it's going to use them or not. So I absolutely agree that like the fewer tools that you can have, because it's the simple solution, right? We keep going back to it. Keep it simple. Make it simple and no simpler, right?
Yeah, and Jamie, you made a good point, because the hallucination problem is really a result of either too little in the context that it's so naive, or too much in the context that it's over diluted. And so it doesn't have the ability to be able to find the signals to give you your answer. And then it has this weird characteristic that it's going to give you an answer no matter what. And so I know so little, but you ask me a question, I'm just going to guess at the answer.
Mm-hmm.
You ask me a question, but I know so much that I don't have time to go through it all. So I'm going to just take the top couple that I find. And as a result, the response from these LLMs, we call it hallucination, but it's really the best effort given the terrible amount of context that it has. So if you can provide it fewer tools, if you can provide it fewer prompts, there is nothing better for any agent than saying new session. Right? That is how you create better answers all the time. You might feel like you have this session, you've been training it so long and you've told it so much, it has so much context that now when you ask it, it'll finally have the answer that you're looking for. But the reality is, if you've gone that far, it has no choice but to go through compaction. And so it doesn't go through compression. So compression is where you take all the data, compress it into something small, but then you explode it later and decompress it. That's not what it does, because it is still a token limit inside the context window. The only thing that it can do, compression is out of the question, is compaction, which is summarization. So imagine you and I are reading to each other, and you're reading to me the cure for cancer. And it's, let's say it's 10,000 lines of formula. And we get to 9,000 of those lines. And I'm like, hang on just a second, I need to do compaction. And I take the cure for cancer that you've been reading in the last 9,000 lines, and I summarize it. It's absolutely destroyed. And so once we sort of understand the mind space of these LLMs, and we stop, pretending like they're, God, then all of a sudden we're like, oh, we can really use these effectively and in a reliable way. And so you're right. That's the reason we minimize the number of tools inside the SQL MCP server. However, if you do have 10,000 tables, or you have 20,000 tables, or we have customers with 5,000 schemas, then the tables come next. It is crazy what customers will do. And they're always the ones who write the biggest checks. So we have to say, yes, sir. And it is just one of those things where we're like, yep, now we could support 5,000 schemas. Actually, we could support more than that. And if you do have that size of a database, the reality is the information needs to be provided somehow back to the model so that it can do it. Hopefully, you've done that first step of narrowing down the access so that you don't provide everything anyway. But then what we do is, one of the tools is an access tool into the schema itself. And so they can start to ask questions for specific tables, groups of tables, and things like that you've provided through our abstraction layer. And then we page that to it. So it's nice and slow. We don't just say, here's all, billion of them. And then from those, it can kind of explode those out, say, oh, the customer table, that's the one I was looking for. Tell me all the columns. Describe every column in detail. And so now it can kind of grow the information it needs, but it can do it slowly but surely with only the objects inside of the database that are relevant. And I would say since GPT 4.1-mini, the agentic workflow has been pretty successful. I have a lot of customers who are doing internal solutions that don't have access to OpenAI or to Microsoft Foundry to use models, and they are running Ollama, and they are still having the success of this kind of workflow to say, oh, with only 7 tools, I need 2 hops instead of 1. The first hop is to say, describe the structure. The second is to do the read, or the second is to do the update. That's totally fine. There was a time when agents really struggled with this workflow. They needed one thing and they would lose track. But that's really not true anymore. The sophisticated flow is second nature. It can do it on the back of its hand. It's not that big of a deal. And so that's been a great success story for us as well, to know that we can kind of leverage the internal capabilities of these models, and we're providing tools that are sort of built in. It knows exactly what to do. We, of course, provide semantic information with SQL MCP server out of the box so that when a model connects to it or when an agent connects to it, the first thing it does is it lists the tools, and we provide very detailed guidance back to the model to say, this is SQL MCP server. On the back end is a database. Here's how you use our tools. And that has proven to be exactly the recipe needed for success. And it has been a real roller coaster ride of excitement to watch customers enable this, kind of cross their fingers, close their eyes, and push go. And it still works. They don't have to do all of these extra instructions to make sure that their agents can follow a workflow. They just can right out of the box, in part because of the semantic data that we provide and because of the internal capabilities of these models.
So you're saying we don't have to do Hail Mary-driven development, right?
Hail Mary, that's exactly right. Squint, and click. That's exactly right.
Brilliant.
It's a big deal. One other thing I think is worth at least talking about before we wrap up here is the idea of embedding. And so embeddings are different, right? So embeddings are the ability to find semantic similarity between 2 natural phrases. We would have, for example, you could search dog and find puppy. Well, that's really valuable. And the way you would do that is you would take a sentence. You wouldn't take a paragraph. You would take a sentence, and then you would embed that into a vector. And of course, SQL Server can take vectors now and just store them natively. And then a vector is just an array of floats. Well, it's really important to recognize that you wouldn't take a paragraph and embed it, because that vector might be an array with a dimension size of 300. Let's just make it big, 1,000, maybe. Well, that's because now I can take it, provide it to an embedding model. Now, that's not the same as an LLM. This is the embedding model. So the embedding model takes my sentence and it sees, this is a game that's fun on vacation. And that's the sentence. And it's like, oh, okay, I can embed that. And now I can search for things like winter break, and vacation still shows up. And I can say game, and I can say entertain kids, and it still shows up. And so it's really nice to have that semantic thing. All of that information then gets jammed into that one array. That's the reason that if I had 2 sentences and I was trying to embed those, if I tried to put them both into that one array, well, the data has to go somewhere. There are only so many dimensions. And so now I'm like, oh, okay, 2 sentences jammed into one array. Now I'm starting to lose information. An entire paragraph of 5-6 sentences all jammed into one array. Now I'm, really starting to lose information because I've had to, summarize the entire paragraph, then embed that summary instead of the paragraph itself. That could really be a bummer when you're looking for something specific inside of your relationships. And so that the solution, of course, is chunking, where chunking takes a long natural string and breaks it into predefined sizes and then embeds each of those predefined sizes while still remaining related to each other. The reason I'm bringing this up is another feature of SQL MCP Server that we haven't really touched on is internal embedding. And so we have the ability, and so right now we just went GA with 2.0 and 2.1 is right around the corner. 2.1 will have the ability to have, just like you can say /API and get to all the REST APIs, /GraphQL and get to all the GraphQL APIs, /MCP, get to all the MCP tools. Now you'll be able to say /embed, and it will take a natural string from you, and it will chunk it. First of all, it will chunk it for you based on a strategy that you provide or our default strategy, and then we'll embed that for you as well, returning back an array of arrays, right? Because you might have to chunk each one representing a chunk of all of those vectors that you can then insert into your database or use in some application that you have to be able to do the mathematical similarity between those arrays. Because when you're thinking, or when people say semantic similarity between two strings, they don't mean it. What they mean is the mathematical similarity between two arrays. We can do that without a model. We can just run, it's a cosine distance, and all of a sudden we can start to figure out what's closest. And what's beautiful about that is the embedding process is actually a complex process. And we're trying to simplify that by making it just an internal subsystem of SQL MCP server. So that I have this string, I would really like to make it so that I could embed it. Now I have to build an embedding pipeline. Whoa. Maybe. Or you just take SQL MCP server and embed it that way. And then we'll have addition. So the next feature, not to talk too far into the future, but the future of SQL MCP server. This is one of the few times, Jamie, that I feel like Microsoft is like 3 steps ahead of our customers instead of 3 steps behind. And so instead of running to catch up, we're kind of where they're going to be tomorrow rather than where they are today. And so one of the next things will be, would it be possible for me to pass in a natural language string and then find the property, or find the record that matches that inside of my database? Well, that's very complex. SQL Server has a solution. Postgres has a solution. Cosmos DB has a kind of solution. But I'd like to centralize it and simplify it so that I can just do it at the API layer. We're still going to use the same embedding model that your corporation already uses today. We just hide all of the complexity. And so where 2.1 is going to have an internal embedding system, 2.2, we actually call it phase 4. We have this next thing where we'll be able to do a semantic search against a table, and even against a table in a database that doesn't have semantic search capabilities. So this isn't really relevant to SQL Server 2025 because it's all built in. But not everybody gets to use, like you were saying, you're constrained by whatever your company has. And so if you're back, you're like, we're still 2016. Great. Now we have semantic search against the 2016 SQL database. So when you start seeing the future vision of how we're continuing to evolve this, and by the way, it's not like we're adding a license and a fee to this. It's still open source and free. And so very, very exciting. And because you are the one who determines how to host it, you are the one who gets to determine where it's going to live, how much it's going to cost. Like, it's great that we give you all of that capability as well. So what do you think of that, Jamie? Kind of neat, right? Around the embedding scenarios.
Yeah, that is genuinely really cool. You know that moment when a technical concept finally clicks? That's what we're all about here at the Modern.net Show. We can stay independent thanks to listeners like you. If you've learned something valuable from the show, please consider joining our Patreon or buy me a coffee. You'll find links in the show notes. We're a listener-supported and, at times, ad-supported production, so every bit of support that you can give makes a difference. Thank you. Just real quick to check my understanding of what you're kind of talking about there. With a fake example, let's say I'm a Walmart-like, CVS-like, Target-like, Trader Joe's-like, Amazon-like system, right? I've got 1 million products. I sell them all in retail stores.
I love that you used Amazon as an example, by the way. Amazon is Azure's largest customer. A lot of people don't know AWS is hosted on Azure.
Oh, that's really interesting. Okay, right.
No, Jamie, I'm joking.
I know. I'm just being silly, right? Wanted to go with it. See if problem is that somebody's going to listen to that and take it as serious, and then
that's the soundbite they'll keep.
Yeah. But let's say I'm some kind of physical store retail supermarket chain, right? I'm a CVS style, Trader Joe's style, the kind of store where you can walk in and you can buy all of your groceries. You can buy, over-the-counter medication. You can buy frozen goods. You can maybe the kind of place where you can also buy like sporting goods and things like a Walmart or something similar, right?
Mm-hmm.
I'm one of those, and I want to be able to search for all products that are rated as maybe diabetic friendly, right? Whatever, like the melatonin pills, pain medication, snacks, groceries, all that kind of stuff. If I have something that can take semantic meaning from the descriptions of the products using embeddings and things like that, and if I train if I use the the kind of embeddings and chunking and stuff like that will allow me to do that. I can then say to my agent, which has access to the SQL MCP server, say, find me all of the products within a certain price range that are not going to hurt me because I am a person with type 2 diabetes, right? And I'm interested in snacks. I'm interested in any kind of this, that, or the other. And then it will go, cool, okay, right. Talk to the MCP server. Server goes, right, I will go figure all of that out. And then it returns a list of products, right? Maybe I'm mid-afternoon and I want a snack. This is a really niche, specific example, right? I'm hoping somebody doesn't need to build this, but it's niche, middle of the afternoon. I want a snack. Maybe I have type 2 diabetes. I can say to the MCP server, I will say to my LLM, go look at my database of products, find me the thing that I can eat this afternoon that isn't going to cause me any problems, go. And then they could use those semantic embeddings to find the products that match that thing, right?
Yeah. I maybe a more exciting example might be, I want something that's healthy and won't melt in my car in the heat. Right? I mean, that's an incredible way of saying it, right? You're like, what? And all of those things can be drawn out from the. Now, if you don't have healthy descriptions, I shouldn't say healthy because I just used an example of healthy. If you don't have robust descriptions on your products, that's going to be difficult to have semantic success in that search. But if you have very robust descriptions and they're provided through some sort of vector embedding, then you have all kinds of cool options. Everything that you said, you could do absolutely. And a little bit like data projects, how they say like 90% of data projects fail. Mm-hmm. Part of the reason is getting your data prepped and ready is so difficult that's the reason. Semantic success is also part of a data project. Like you want to make sure that you have your data prepped and ready so that when you do the embedding, it's excellent. Because I can say, if we go to one of your examples that might have hundreds of thousands, perhaps even millions of products, depending on how they do their SKUs, then the embedding time and potential compute cost is pretty high. And then you're like, oh, I could make these twice as robust and have a better search result. Now you have to re-embed all of those if you're going to do it properly. And so that's which one comes first? Do you want to test this out on your entire data set, or do you want to fix your data set first and then try it out? And so what you came up with, this kind of very nice use case that I imagine is very realistic, is extremely successful when first the data is robust and then embedded, and then you can do these searches. By the way, the search relationships between all of the different chunks, remember, it's not just against the products, but it's against the multiple of how many chunks there are in its description as well. That relationship is incredibly compute expensive. And the reason I say that is I want to be able to find the relationship between, and I'll pass in diabetes, let's say, but I'm not really looking for things that are for diabetics. I'm just looking for things that are related to sugar content and stuff like that. If I have 100,000 products, each has, let's just say 10 chunks. Now I have 1 million. Each has their own relationship to the rest of the 999,999 objects. Well, that graph is extremely expensive to compute if that's the search I'm going to do, and I just have to now compute 1 million of those. So the way SQL Server does it, and again, now we're outside of SQL MCP Server, but the way SQL Server does it is it pre-computes the relationships in a relationship graph across all of those vectors and then stores it on disk. And I mean, it's intense, right? And this is a process that Microsoft Research invented several years ago, and now we've implemented it. And it's the only way to do it. Like if you were going to try and do a semantic relationship between two vectors, not a big deal. If you're going to try and do a semantic relationship between 1 and 1 million other vectors, incredibly, like not only does it melt all of your servers, but your users are frustrated by waiting an hour for the answer. And so that's the reason you have to start looking at all of these additional, humanity is amazing right now.
It is. Jerry, thank you for being with us today. I feel like my knowledge of AI, MCP, and SQL has just exploded. Every time we speak, I feel like I walk away with a whole syllabus worth of new information. So thank you for that. I really appreciate it.
There's a lot here, and to be honest, there's so much we haven't covered yet as well. Data API Builder or SQL MCP Server is just a big product with a lot of things. and yet somehow is still small and it's this easy thing to add to a solution. If I were one of your listeners and I was wanting to get, some information and maybe be able to discover it myself, I would potentially start with our docs. AKAMS/dab/docs takes us directly to the docs. That'll take you both the MCP docs and the REST docs and the GraphQL docs. Everything is in one place as well as authentication. That being said, I do want to say that it's aka.ms/dab. Without the docs, it takes you to the open source repository. And so this is on GitHub where everything is in the open. We're building this. The roadmap is in the open. Our issues list is in the open. Everything is in the open. And perhaps most interesting is our roadmap, where you can go into the discussions area of that repository and not just our backlog, but be able to see exactly what we're planning in the next handful of versions and releases of Data API Builder. That's pretty exciting too. There are many different videos and kind of walkthrough tutorials that you can find on YouTube or just kind of Googling for as well. A lot of them are directly accessible inside the docs also. But if you're just kind of wondering where to get started, that's probably the easiest way. And it's an exciting place to go. I mean, if there was a word of encouragement I would give to you and to all of your listeners, it would be, remember that all of us are figuring this out right now. And so it may seem as if everybody's talking about AI, but everybody is talking about AI at the kindergarten level right now. And so this is the right time to get involved, the right time to start engaging, the right time to listen in. When you think about like the HTML spec, I mean, you and I kind of had the luxury of being part of it as it was growing. This is the AI spec. Like we are at this luxurious time where everything's slowly getting figured out and we can sort of absorb it as it's happening, rather than trying to swallow the entire apple later. And so this is a neat place to be, a neat time to be. It's pretty handy to be able to use a database like SQL Server to do a lot of these capabilities. It is extremely handy to use SQL MCP Server, which isn't tied only to SQL Server, but also Postgres and MySQL and Cosmos DB as well. But depending on what your internal requirements are, it's a neat option to have in your toolbox.
Yeah, it really is. I'm looking forward to getting to play with it myself. I've got a few days where I don't have any pressing work required, so I'm going to maybe see if I can create a database with loads of data in it, or maybe just grab is it the SolarWinds? Are those databases still around somewhere, something like that? Just grab a open source database with lots of data in it, throw SQL MCP server at it, and see what I can request and see how it works, right? Maybe that's a good way to start, right? Find an open source database somewhere that you can poke at with it and see what happens.
Absolutely right. That's a terrific way to get started. Here's a little treat you can give to your users. AKA/ms/dab is the URL I told you before. AKA/ms/dab/meet allows you to schedule a meeting with me. So if your manager has a lot of questions, your lead dev has a lot of questions or something like that, I'd be glad to talk to you or whoever your listeners are as well in a short meeting or whatever is necessary to kind of give you the confidence to make an architectural decision.
That's awesome. Thank you very much for that, Jerry. I really appreciate that and everything we've talked about today. I appreciate your continued patience with me whilst I ask the potentially really silly questions and fumble my way through thinking of examples and things like that.
It's been a delight, Jamie. Thanks for having me on again.
Thank you very much, Jerry. Always a delight to speak to you. Thank you for listening to this episode of the Modern.net Show with me, Jamie Taylor. I'd like to thank this episode's guest for graciously sharing their time, expertise, and knowledge with us. Be sure to check out the show notes for a bunch of links to some of the stuff that we covered and a full transcription of the interview. The show notes, as always, can be found at the podcast's website, and there'll be a link directly to them in your podcatcher. And don't forget to spread the word. Leave a rating or review on your podcatcher of choice. Head over to .netcore.show/review for ways to do that. Reach out via our contact page at .netcore.show/contact, or join our Discord server at .netcore.show/discord, all of which are linked in the show notes. But above all, I hope you have a fantastic rest of your day, and I hope that I'll see you again next time for some more .NET goodness. I'll see you again real soon. See you later, folks.